So let's go and check what this question is all about. Right. So this question says to us here, in the figure, M is the center of two concentric circles, right? The word concentric is a very funny, fancy word for these guys share the same center, right? So when you say two circles are concentric, you're simply saying they're sharing the same center. The larger circle has equation x squared plus y squared equals 4y minus 2x plus 44. The line y plus x minus 5 equals 0 is the tangent to the smaller circle at point A, right? Okay, K is the x-intercept of the tangent AK. B is a point on the large circle such that MAB is a straight line. All right, cool, right. Now that's very, very important and useful. Now, let's go to the C to see what's the first question all about. Okay, now we are required to determine the coordinates of M, right? What is this M? M is the center of the circle, right? Now, you guys need to understand that the analytical geometry we're doing in grade 12 only involves a circle. There's nothing that you guys have seen before that is going to be new. Everything that you're going to see comes from grade 11 as well as grade 10. The only thing we're adding now is just the equation of a circle, which is x minus a squared plus y minus b squared is r squared. From there, you can be able to read the coordinates of the center, right? Now, if you look at the question that you're sitting with here, we were told that the equation of the larger circle, right, is x squared plus y squared equals to 4y minus 2x plus 44. And we can't be able to tell what the coordinates of the center is unless if we can succeed to write that in the form x minus a squared plus y minus b squared equals to r squared. Because this number that you're going to have here and this number that you're going to have here will form the coordinates of the center of your circle. It is always the case. If you haven't heard anybody talking to you about a circle, then you need to know that the number you've got there and that other number b there will simply form the coordinates of the center of the circle. Now, if I can succeed to convert what you're looking at there as the equation given in the love letter of the larger circle, that equation given there, if I can succeed to rewrite it in the standard form that you're looking at there in yellow, then I can be able to see what the coordinates of the center, which happens to be M, are in this case. So let's write that down and try to see how we can actually manipulate that question so that we can see the coordinates of the center. All right, so what do we know now? We know that we were told that x squared plus y squared equals to something, which is what? 4y minus 2x, if I'm not mistaken. Yes, 4y minus 2x. So we're going to have here 4y minus 2x plus 44, right? Now, I'm going to try and rewrite this in the correct standard form so we can see the coordinates of the center. Now, in order to do that, what you need is to apply the concept of completing the square. I think you guys were taught how to complete the square in grade 11. You understand how that process works. If you forgot, you're going to need to go and revise how to complete the square. So let's go and check what the story is in this case and remind you how do you complete the square when you're working with what's going on here. So I'm going to first of all group all the x's in order to make my completing the square easier. So that minus 2x will come and join me and become plus 2x here. And then for the y's, I've got y squared minus 4y. And then I don't care about 44, so I'm going to keep it where it has been all the time, which is on the right-hand side. Now, to complete the square, what you simply do, I think you guys will remember, you just take half of the middle term. So in this case, if I'm looking only at the x's, if I'm looking at the x's only, I'm going to only take half of this coefficient of x. That's the number of interest in this particular case. So I'm going to say we have x squared, we've got plus 2x. Now we're going to take half of that, right? Half of 2. We're going to take half of 2 and we're going to square that. That's how you complete the square. So half of 2 is just simply going to be half of 2 squared. But because I'm adding it on the left-hand side, mathematics says what you do on the left, you need to repeat on the other side. So even this side, I'm going to add that half of 2 squared, right? And then I'm going to go to the y's. For the y's, I've got y squared minus 4y, but then I need to maintain the same idea again, the same logic, and add half of negative 4 this time, not 4 but negative 4. The sign matters in this case. So I'm looking for half of negative 4 with the square. What you do on the left, we also need to do the same thing on the right hand side. Just remember to please square them. Everything that you're writing that is new needs to always be squared. All right, so now I'm going to end up with x squared plus 2x plus half of 2 is 1. So you're going to have 1 squared and you've got your y squared there. Let's just try to right? Yes, that's going to be 1 squared plus, you've got y squared minus 4y plus half of negative 4 is just simply negative 2 squared equals to, you've got 44 here plus that's 1 squared again, and that's actually negative 2 squared, right? Now to complete the square, you just simply factorize what you're looking at, the first 3 terms. So what I simply say is, for me to complete the square, I take the square term and take the square term to make a square. That's how easy it is. X squared plus 2x plus 1 is just simply x plus 1 squared. So to complete the square, even with the y's, I'm going to do the same thing. To complete the square, I take a square and I take a square as well. That one is not a plus, but it's a minus. So you have to be careful with the signs. You take the sign as it appears inside the bracket. So minus 2 squared equals to, you've got 44, right, plus 1 plus 4. 44 plus 1 plus 4. And then you'll notice that if you rewrite this, you then have x plus 1 squared plus y minus 2 squared equals to, that's 45. That's actually 49, yes, equals to 49. And then from here you can then conclude that indeed, according to what we're looking at, the coordinate of the center is minus 1 and 2, and the radius is just going to be the square root of 49, which happens to be the 7 value there. So when the examiner was only interested in the coordinates of M, the center, which is now minus 1 and 2. Very powerful question indeed, no complications there. I hope you guys see that you must convert it to this form and then do what I just did here, complete the square, then you can read your center coordinates without any complications. Let's go to the other part of this question. We are told here that now we need to show that the coordinates of point A are 1 and 4. Point A is simply 1 and 4. So let's go and see what this point A is. Point A, point A, point A. There's point A. So point A is this point you're looking at there. Right. So we need to find the coordinates of that point A and show that indeed its coordinates are going to be 1 and 4. Right. Now remember the following. We were told that this is actually a tangent and we were given the equation of the tangent. According to what we know, the equation of the tangent is simply y plus x minus 5 equals to 0. Right. And what we also know is that we have unknown coordinates, which I'm simply going to call x and y here. And then the coordinates of M, we know what M is. We can simply write those coordinates of M there without any complications. We found them to be negative 1 as well as 2, right? Now I can try to create an equation here and then use it to try and figure out what the coordinates of X are going to be. Now if you look at that thing that you're currently looking at, we know that the gradient of that AB, the gradient of AB, right, is y2 minus y1 over x2 minus x1, right? But then we know we don't know what the x values are for that. So I'm going to simply say my y2 here is y minus my y1 is simply 2 over my x2 is x minus my x1, which is minus 1. So I'm going to have plus 1, right? So this is the gradient of that line AB. But now what we know for a fact is that if you look at that line MA and the line AB, those lines are simply perpendicular to each other because the gradient, the radius is always perpendicular to the tangent. So that means I have a relationship between the line MA and the line AK. I can be able to figure out what the gradient of the other line is going to be, right? So I'm going to simply say, if you look at what we have here, if you look at this one here, and I rewrite it in the right form, it's just simply going to say to me y is equal to minus x plus 5. That will be the equation in standard form. And you will notice that the gradient of that line is going to simply be here. There's a minus 1 here, even if it's not written. Now, if the gradient of the tangent is negative 1, that means the gradient of the radius is just simply going to be plus 1. So I'm going to simply come here and put a 1 as the gradient of this. And by cross multiplication, you'll see that you are going to have x plus 1, right, equals y minus 2. And then I can simply say, if you take that 2 to the left-hand side, you're just going to simply sit with y equals to x plus 3. And this can be thought of as the equation of the line MAB. This line, this equation here, can be thought of as the equation of the line MAB. All right, so now I'm going to say, okay, I've got that equation y is x plus 3. I've got another equation y is minus x plus 5. So if you may allow me to create the solution in this small space that you're looking at here, let's see on the left hand side so that all the work is still in front of you guys, you can see what is happening. So I have one equation that says y is minus x plus 5. I've got another equation that says y is simply x plus 3. So I'm going to apply the logic that revolves around the concept of not completing the square but simultaneous equations. So when I equate them, I'm going to have x plus 3 is equals to minus x plus 5. And if you take the other one on the left, you're going to have 2x equals to 2. So your x is going to come out as exactly 1. And if x is 1, you can then substitute this x value that you're looking at in any of those equations. So if I substitute, for example, in y equals to x plus 3, then my y is going to be 1 plus 3, so it's going to come out as 4. And therefore, that concludes the fact that the coordinates of A have to be 1 and 4. Right. I hope you guys see what is happening here. A lot of information that is based on these two circles. As long as you understand that concentric circles share center, and when you've got that center, you can now use any of the concepts that we've discussed before to either find the equation of the small circle or even find the equation of that radius that you have there. So what I simply did here was apply my knowledge of analytical geometry that tells you that a straight line that happens to be a tangent will always be perpendicular to what is called the radius. And the gradients of lines that are perpendicular to each other will always give you a value of -1. So there's nothing new. It's still the same thing as what you guys have been working on it with in grade 11. The only thing is we don't tell you that those lines are perpendicular. We expect you to use your knowledge of Euclidean geometry to come up with that conclusion.